Well, good morning, good afternoon, or good evening, depending where you are in the world, and a very warm welcome to all of you at our webinar today, which is titled Automated Modelling of Steel and Piping, New Workflows for Dramatically Faster Revit and Plant3D Projects. My name's Nick Johns. I'm the business manager here at Excitech, and my responsibilities include the delivery of new products, technologies, and innovation to our design and engineering clients here in the UK. We have a very busy and interesting agenda, so I hope you all acquire some real value from our webinar today. First, I'd like to thank you all for taking the time out of your busy schedules to join us today. We have a lot of you with us, 550 people, which is absolutely fantastic from all over the globe. So a great attendance and clearly lots of interest in these particular topics. So it's great to have you all with us today. I'm going to now introduce you to some of my colleagues who will also be presenting today, and I'm going to ask them to say a very brief hello. And I'm going to continue with the international flavour of our webinar. So we have, first of all, let me introduce you to Otto Weber, the Managing Director of ClearEdge 3D International Business, and he's all the way from New Jersey. So, Otto?
Yeah, I just want to say hello to everybody. Good morning, good afternoon, good evening, depending where you are. And I'm happy to have you join this webinar, especially with the turnout that we have. Hopefully you'll get some good information that'll help you all with your projects as well.
That's great. Thanks very much indeed, Otto. And we're also delighted to have two organisations with us presenting very insightful and interesting case studies. We have Lewis Boxer, who is the Technical Director of Advanced 3D Laser Solutions. Lewis?
Good morning, everybody.
Thank you. And we also have Daniel Niziolek, who is the Assistant Engineer at Ramble UK. Daniel?
Hiya, everyone.
And again, gentlemen, thanks for being with us today. So, we will be recording the webinar today. It will be made available on the Excitech and the ClearEdge website. If you have AUTODESK subscriptions or are a support customer with Excitech, you will have access to the recording. If not, you can register on our website, you can talk to our account managers to gain that access, but we'll ensure that we send a link of the presentation to everyone once the recording is made available. There will be a Q&A at the end, so please use the question box that you should be able to see on your screen, and we will endeavour to answer as many questions as possible at the end. If we do run out of time and are unable to answer any further questions, then we'll ensure that we respond to all of your questions via email. If there are any problems with audios or visuals, please let us know via the chat or the question box, and we'll try to fix this for you. Participants also are going to be muted during the presentation. So, before we progress with our webinar, I hope you will allow me to give you a very brief potted overview of Excitech before we dive straight into the presentations. So, at Excitech, we help our clients to design, construct, and operate better. What does this mean? Well, our objective is to make sure our clients garner a return on any investment they make in technology and process via the services we provide. And that's particularly consultancy, training, software, IT, document management, facilities management, and technical support. And that's what we mean by enabling our clients to design, construct, and operate better within the AEC space. And that's covering architecture, engineering, construction, and owner-operators. We have national coverage with our head office in Enfield in London. We have 2 training centres, and we also have 110 staff that are mainly based in our office in Enfield. We have a comprehensive account management and technical team supporting a plethora of clients across the UK and Ireland. And lastly, and importantly, we are regulated to high quality standards with the ISO 9001 accreditation. Okay, so let's get started. I'm now going to hand you over to Otto Weber, the Managing Director for ClearEdge. And thanks again, everyone. And just please bear with us while we swap screens, should I say. Otto.
Okay, can you see my screen, Nick?
We can.
Okay, so if you could see it, I'm assuming everybody else could see it. Okay, so first of all, I want to welcome everybody to the webinar. I just want to go through the agenda real quick. So introductions were already made. I want to go through some goals and context. We've got two very interesting case studies. We've got Louis Boxer talking about building a loading gantry for a oil refinery. And then we've got Daniel Nisvlik from Ramble talking about gantries for the highways. Both have their own idiosyncrasies on the project.
Otto, I'm so sorry to interrupt. I think your presentation needs to be on presentation mode, Otto.
Okay. Can you see it now? Am I there? Oops, sorry.
Yeah, we're fine. We're good to go, Otto. Thank you.
Oh, sorry. Okay. So as I was saying, we have two very interesting case studies. One is focused on the CAD side, Plant3D, and the other one is going to focus on the BIM side, the Revit. So two separate deliverables and, two separate case studies. I think you're going to find them both interesting. Feel free, if there's any questions that you have, to type them into either the questions or the chat box. We're going to take the questions on a first-come, first-served basis. So get your questions in early, and at the end, we're going to allow some time. And as Nick said, if we don't get to your questions today, we'll follow up with an email and try to answer everybody's questions. So feel free to put your questions into the chat box. Okay? A little bit about ClearEdge. We were founded in 2006, so we've got over 10 years of automated feature extraction expertise. So we truly are the pioneers of the automation of 3D models from a point cloud. Our goal is to reduce your modeling time by 50 to 75%. We're consistently hitting those numbers with our customers. The return on investment, as you'll see in the case studies, is very easily realized on your first project. We do provide a competitive advantage to our customers, and you'll see that today as to why. Working with a point cloud, as you know, can be pretty tedious, and we take care of that. Since the software does the heavy lifting, there's less time for you to spend working with the point cloud. Again, because the software does the heavy lifting, it's easy to use, easy to learn. Our learning curve is probably about a day, and you're almost an expert with the software. We are compatible with all the major terrestrial scan filers out there, whether you're using Faro or Leica or Topcon, it doesn't make a difference to us. And we integrate with both Revit and CAD, and by CAD I mean various CAD software. So if your client wants an AutoCAD deliverable or a Plant3D or MicroStation, you don't have to learn new software. It's just a export for us. So that's some of the benefits. We truly are almost like middleware in terms of the capabilities that we offer. Okay, in terms of the presentations, Louis Boxer, he's got quite a bit of oil and gas experience, and he's going to go through an interesting gantry project for oil refinery. Daniel Nisvlik is going to take us through the gantry on UK highways. And Nick Johns, which you just heard, is going to tell us a little bit about the Excitech, which he did, and he'll do a summary at the end. Okay, so at this time, let me see, let me move this here. Okay, I just want to go through something, we typically have, the client needs, we have the pain points, and I want to make sure, that we understand the value proposition. I'm assuming, to set the context, that everybody is familiar with laser scanning and you have an idea of the value that it provides. I know we have a lot of people on from around the world, and you may or may not be familiar with it. So I just picked three that are important points. On the client needs side, the first one is minimize downtime. The pain point is if you're in a facility, as Louis is going to present today, and you've got downtime, you've got costs associated with the downtime. In terms of the value proposition, if you get an accurate as-built data, it enables much better planning up front. Okay. The second one is minimize uncertainty and risk. And again, the pain point is unforeseen problems can cost time, and it'll certainly cost money. So again, the value proposition is that it minimizes unexpected challenges. In terms of field revisit, if you're scanning it, you grab all the data. Typically, there's no further field revisit, which is a cost. From a safety perspective, which you'll see today, if you're trying to send somebody out and doing it the old-fashioned way and taking, measurements on a highway where cars are going by, there's a potential safety issue. And the project that Lewis is going to present today in terms of sequencing, if you're doing a Plant3D model and you're using it for clash detection, you're able to very quickly see where things fit, whether you could move a piece of equipment in or out and you have enough clearances. So there are some really potential benefits. In terms of the reduced project schedule for both maintenance and for project. If you reduce your schedule, you certainly reduce your costs. And the intelligent 3D models actually reduce the schedules, from a clash detection, from not sending somebody else out to the field. And also, you could use the 3D model to facilitate preventative maintenance for, any future work. Okay, at this stage, I'm going to turn this over to Lewis Boxer. So, and Lewis is going to present us with our first case study. So, Lewis, I'm going to turn it over to you, and it's all yours.
Good morning, everybody. Thank you very much, Otto. So, my name is Lewis Boxer. I'm the Technical Director at Advanced 3D Laser Solutions. I invite all of you to have a look at our website, lasersurveying.com, which outlines a lot and shows you a bit about point cloud data and the other services we have. So, we at ALS actually specialise in the oil and gas stroke process industry. We use modern 3D scanning technology to map your sites for analysis and documentation, and and we're constantly using new technology and applications to try and meet client needs every day. So the directors, so there's 3 directors: Graham Boxer, who's our managing director and father, and myself, Lewis Boxer, and Colin Pittman, who's our commercial director. So feel free to obviously contact Colin, and you pass on any details about our company or a brochure, whatever you require. So our other services, I'll go into this very brief. Obviously we do the 3D laser surveying, and we do that all across the country and around Europe as well. We do a lot of tank analysis for oil storage depots and refineries, which comes into guidelines for EMUA and API 570, some of you might have heard of. Do a lot of piping isometrics, and this is something that the piping isometrics that we produce are actually exported from the 3D model that we use the clearage to help build. And again, this is for PSSR and API 653. We also do a lot of 2D, like traditional surveying and 2D piping isometrics, piping and instrumentation diagrams, PNRDs. Do a lot of 4D video fly-throughs. Is something that's becoming incredibly popular with us. So the next slide, I believe, I'm not sure how well you're going to see this, but this is a quick 10-second video just showing you what a point cloud is. And this is one of the 4D video fly-throughs. And this is literally created just from the point cloud data, and nothing to do with the photos or anything. And these scans are taken from grade level. And a lot of people are using these for marketing and health and safety, induction videos for their sites. Okay, so like Otto was saying, today's case study is about a road loading gantry that we had scanned for a client. And the client has said that it would be okay to use his name, and the client was actually Flowtech. They were designing a new road loading gantry, top loading one, and I'll come into all that. So, the brief. The client's project was to design and build a replacement of the top loading gantry that was on this site. And this gantry was basically loading feed oil straight into the top of a road loading tanker. The objectives, this particular area was incredibly tight. It was a very small area, and there's a lot going on, a lot of pumps, a lot of tanks, a lot of steel work, a lot of pipe work. There's a real spaghetti junction. The client was trying, because they're a design contractor, they obviously got surveyors themselves, but they were trying to go up with the tape measures, traditional ways of doing it, and coming back off site, getting back to the office the next day, looking at their markups, and were just struggling to get anything to align. So they're constantly going back, taking new dimensions. So that's why they contacted us. So we at ALS came up with a solution to go in, scan the existing gantry and produce a 3D model so they could use it for clash detection, so they could work out not only where they're going to fit this new gantry, but exactly how they're going to get the old one out and how they're going to put the new one in. So, the scanning workflow. So we actually use, most of the time, a thorough focus. We use 12 spheres, and these spheres, for people that don't know much about laser scanning, these spheres are literally just white footballs. They're about 145 mil in diameter, and they've got magnets against them, which enable us to magnetize them to steelwork or put them on tripods. We use a lightweight tripod with the scanner. There was no need to use a heavyweight one. Traditionally, a heavyweight, we a bit like a one you'd see on a total station. We completed 14 scans, and we did that within about 4 or 5 hours. The scans were only 6 minutes each, because everything was so tight. There was no need to rank up the settings, because everything was very close vicinity. And we did coloured photos. It's not something that was necessary, but we do find that once we've done the scanning, clients are like to see the web share and like to see the photographic images that come from laser scanning. And again, for people that don't know much about laser scanning, the laser scanner goes through 2 phases. The first phase, obviously, producing the point cloud file, which is basically the video that I showed you a minute ago, and the second phase is producing the photographic images. So moving on, the point cloud processing. So once we've done all the scanning, we have to actually process them. We have to actually stitch them together, and we use the Faro Scene software. That is obviously the software that comes with the scanner, and because it was only 14 scans, I think I said, it was very quick, and as you can see there in the background, there is just an image of it showing you the intensity value of the point cloud. So to model out what the client required was obviously the steelwork, the major steelwork to be modelled out, the handrails and the pipework around the vicinity. So we, for 99% of all of our modelling jobs that we use, the ClearEdge Edgewise Plant software. We've used other modelling software before, and I'll come into that a little bit later. So the first phase that we went through was to model out the pipework. The reason we kind of went through just doing the pipework first was I was able to export it out, something I'll come into later, and give it to one of our other 3D operators, and he was able to model out the existing stuff. Again, I'll come into that. So the ClearEdge software is all automated. So all the pipework that you're looking at here is everything that it was able to find, the Edgewise software. You go through a function of cleaning up some false positives that it's found, sometimes a bit like lampposts, and then you apply the elbows, and again this is an automated function. So it does pick up on a good 90% of all the elbows. So the automatic extraction, which is the Edgewise software versus manual point sensing. We've used multiple other pieces of software, all of which were manual point sensing. And for the size of projects that we normally do, for instance, this particular project, if I go back one, we would class this as a very small project. Some of the projects that we've been doing have been up to 500 to 600 scans, something that we've completed with multiple scanners. 2 or 3 scanners with 2 or 3 teams of people going out. But the manual point sensing is very slow. and it has a lot of limitations. For instance, it's unable to find, it struggles with where pipework lags and has bowed over time. The Edgewise software, we only model out the pipework within the Edgewise software. It can obviously model out the flanges and piping equipment, including valves, but we do find it's easier for us to export the pipework from the Edgewise software into Plant3D and add the valves and the fittings using Plant3D because of the catalogue that we normally use. Like, we might use a carbon steel £150 or £300 or stainless steel fitting catalogue, and it's all been built, something that we've kind of created and modified over time. So obviously from Edgewise we can export the pipework from Edgewise and import it into Plant3D. This is something that Edgewise have created, and this is something that we worked on with Edgewise or ClearEdge to produce because of our background with Plant3D. We went through quite a couple of different software import and export functions until Edgewise almost nailed it basically. It's very fast, it's very quick, and it's very accurate. So it's one of my key points was that when we exported it from Edgewise, that I made the clear point that it had to be still aligned with the point cloud data, because obviously we take one copy of the point cloud data, put that into Edgewise, and we put one copy into AutoCAD, and I wanted that AutoCAD point cloud to align with the Edgewise pipework, which it does absolutely perfectly. There is a few drips that it does export out with. Obviously, brownfield pipework is never perfect. It's going to be bent, it's going to be pushed, it's never perfect, and you're not going to find any software that's going to be able to pick up on that perfectly. And this is more of a limitation with the Plant3D software than the Edgewise software. So this particular image, this is showing you a snapshot from Plant3D. And as you can see here, we've actually put in some of our the valves and fittings, including pipe supports and flanges, all from ASME catalogue. We've coloured the lines in red. These particular red lines was what the client would be modifying. They were planning on actually removing these two valves and then bolting on their new road loading gantry. So we put them in red just to make it a bit easier for them, so that they were impressed by. So the second phase was to model out the steelwork, again importing all the point cloud data, allowing it to produce the Edgewise database. Well, actually, we'd already created the database, so it was simply building a new model into the tree view, which was a structural model, and we went round and basically identifying all the steelwork, the major steelwork which the client was required, and obviously you can see a few I-beams here. This was one of our first jobs using the steelwork function. We've used it before for marketing just to show people like a few images of what we can do with it. It's a very quick and easy function. It's a semi-automated function. This is something that Daniel will be going through in a lot more detail later on, but it's not something that we've particularly used. We use it on a little bit, but not a lot, because the steelwork that we, for instance, did for this particular job was very quick and it was only a small area. Some of the tools that we use in Edgewise that we particularly like is the first one, which is a major one, is their Smartsheet, and this is something that I haven't seen in any other software for when it comes to point cloud recognition. So obviously you can see on the left here is a cross-section of a piece of steelwork, and you can clearly see the green outline of the point cloud data around it. So we're able to literally pick up this 2D representation of the I-beam and move it over to the point cloud to perfectly represent what is on site, which is really quick and really easy. It's something we really liked. So the other function is the resize function. So, for instance, if this particular I-beam didn't come in anywhere near it, we can quickly use our resize up here and quickly draw a clipping box around it, and it will look through the catalogue that you specified up here and find a better fit, which is again really quick, really easy to use. The last function is the set to selected, and I'll come back to this previous image. As you can see, some of these vertical beams are all exactly the same. They're the same spec. So once we've modelled out the first one, we can literally set the selected and it will lock in that particular size, so we can model in the other 6 or 7 that we've got here, and we know that they're exactly the same spec as the previous one. And this is something that we use a lot, just to make sure that we've got consistency. Again, once we've done this, we can export this into AutoCAD. It exports into a COE format, and I'm not quite sure what that means. But it's a piece. It requires a piece of third-party software, which is free, as a Leica piece of software, and it goes in absolutely seamlessly. It's actually perfectly easy. Again, here's the snapshot from our Plant3D model, so you can see here exactly how it comes out. And I'll show you an image later of it all coming together. So the third function was this, was our handrails. This is something that the client kind of decided on last minute, and which is absolutely fine. We had all the point cloud data already in there. So we did this slightly differently with the, which I've left out, with the pipework modelling. Now if I quickly scroll up. Once you've modelled all the pipework out within edgewise, you actually apply a spec to it, and I believe it's an anatomy spec, a carbon steel 150 pound spec. So instead of it being a 50 mil diameter pipe, all of a sudden it turns into a 2-inch diameter pipe. And this is something that's crucial when you want to export into the Plant3D format. And I won't go into too much detail of all that, but it's all documented, and there's plenty of videos out there to show you how to do this. But back to the handrails, we did this slightly differently. So we actually again modelled it out using the pipework extraction, and added the elbows a lot like we did with the pipework, but we didn't apply the spec to it. The reason we did that was obviously some of these elbows aren't 90-degree elbows, and they're all custom elbows, and I can imagine a lot of this was bent into place just on the day. So to keep accuracy, so it was incredibly accurate, it was incredibly tight against that point cloud, we exported it straight out from the edgewise into a COE format, a bit like what we did with the steelwork, and imported it straight into Plant3D, and we found that this would be a lot more accurate, because this pipework isn't ASME spec. It's not 1 inch. It had a diameter that was read in millimeters rather than inches. So that was the functionality. But again, you have within the spec, the smart sheet, you can actually pick up on this and say, look, this is all 20 mil diameter tubing, so it is all consistent. So exactly what I went through. We manually went around and modelled out the cylindrical handrails. Again, something like this took us only about half an hour, probably not even that. So it was a very quick function. Something that surprised us actually. I wasn't quite sure how we was going to go about this, but as soon as we loaded it up into the edgewise software, it ran perfectly. Again, like I said earlier, we exported it as an AutoCAD COE format. Very quick, very easy. So no piping standards were applied. So all these elbows and sweeping bends came out perfect, exactly how we wanted them. And so this was a bit of a unique project challenge for us. But again, it ran smoothly. So the AUTODESK Plant3D workflow, I've explained how we export from edgewise and bring it into the Plant3D. The edgewise supply their own spec, and I think it's called the edgewise spec. something that you load up in Plant3D for people who know how to use Plant3D software. We export all the point cloud files from Farasene and import them straight to Recap. And Recap basically converts those .fls files for Faro into a recognised file format that AutoCAD can open. And the benefit of using Recap as well is it enables you just to crop out all the areas that you don't need, because anyone that's used to point cloud data, because it does record absolutely everything, which is a huge advantage and a huge benefit in laser scanning, but it also means that those files are absolutely huge and it will pick up on a lot of data that you're not particularly interested in. So that was the Plant3D workflow. So I'm skipping out a lot here. So import when using Plant3D plugin, use the Plant3D catalog, and because obviously there was a couple of different piping specs here, there was a stainless steel pipe spec, there was a carbon steel 150 pound spec, and again we just used the Plant3D catalog to do this. It's just something that we're used to. We also model out the equipment, so this includes some pumps, a couple of cylindrical tanks and a couple of cube tanks. Again, something that we've done in Plant3D, something that again we're used to. We applied the line numbers within Plant3D and tagged equipment. The reason for this is that once we've modelled all this, it wasn't a deliverable, but if they came back, they can export piping mathematics or produce piping orthographics, something that's becoming incredibly popular for NDT use. Very quickly. So this particular client, the client that I said earlier, Flowtech, they were modelling or designing their new road loading gantry using SolidWorks. This was absolutely fine. This is something that we've done a couple of times with clients. So we use the AUTODESK software just because there is something that we've got a background in, and we know that we can export into a multitude of file formats, allowing people to open them up in stuff like SolidWorks. And they're perfectly happy with that, and they're really pleased with the accuracy. So the conclusion, the advantages of using the Edgewise, it's vastly faster than competitor software. I'm not just saying that. I've used other competitor software, and I'd used it for about 3 months, and it's me and Otto were talking, and whilst I was using this other software, and I just at the time there was no Plant3D software or export function, so it wasn't something that we wanted to jump into Edgewise until they got that sorted. But Otto saw the opportunity there, so we worked together with it, and at the time we had 5 oil storage depots to do at a time for a particular client to produce these piping isometrics, and scanned all the sites perfectly easily using 1 or 2 scanners. Took about 4 or 5 days each site, very quick. But it was the software, and this particular software required that you had a license for Plant3D and their license. So you was using 2 licenses at the same time, and it was costly and just very slow. So I spoke to Otto. He said that they were producing the Plant3D export function, their own program. So we used one of the point cloud file projects for one of the terminals, imported it straight to the Edgewise software, very quick. Watched a couple of their videos. Well, they had about 10 or 11 videos, all different functions of how to get through the workflow, basically. Very quick, very easy. And we modelled out the sites. So for instance, the manual software took us, I believe, about 2 months to do 1 terminal, something that we quickly realised wasn't going to be meeting guidelines and prices. We used the Edgewise software, and it took about 2 weeks, I reckon. Probably about a week to use the Edgewise software, to quickly go through all the automation software, and about a week to clean up a couple of drips and add all the equipment and the piping equipment, including pipe supports and flanges and valves and whatnot. So, like I said, the Edgewise has got a fast user interface. There's a lot of shortcuts using your keyboard, which anyone using AutoCAD would absolutely love. Everyone loves their shortcuts. And like I said, it's a very quick learning curve. So the disadvantages. The Plant3D plugin does produce some drips, but like I said earlier, when you're scanning and modelling pipework, existing pipework on brownfield sites, it just doesn't line up. You can't expect to model existing pipework in a greenfield piece of software and expect it to line up absolutely perfect. It just doesn't work out that way. So it does require a bit of manual fixing. The export to COE, it requires a third-party piece of software to import into AutoCAD. Again, it's absolutely free, and it's just maybe me just being picky, but I'd love to see maybe an export function that exports it straight into a .dwg or into the native AutoCAD format. The only other function, it's not a huge issue, but I'd like to see the elbow-to-elbow modelling. On Edgewise, it doesn't allow that at the moment, so you have to model in an elbow, put in a small piece of pipework, and then model in the elbow onto that. It's certainly not a deal breaker, but it's something I'd like to see in a future update. So tips. So one of the Edgewise guys spoke to me. He said, "Could you give us 3 tips for other as-built modelling managers?" So I had to think about that, and the only 3 I can come up with is, the first one is to keep your SDK files up to date. If you use the Faro software, obviously they've just brought the 6.0 software out, but through years you jump into like 5.3, 5.4, 5.5, 5.6, and we're constantly updating those files, and sometimes installing the Faro scene software isn't enough to update all your software, including Edgewise, with the SDK. For instance, the AutoCAD Recap doesn't like it either, so you have to just download the most recent SDK file, quickly run it, which takes like 30 seconds, and it's up to date. But if you don't, you do find a couple of issues, like, for instance, again with Edgewise and Recap, this is that when you drop the FLS file format in there, it will start doing it, and all of a sudden it will start either getting slow or just stop. It's a really odd, it doesn't give you an error or anything like that, it just stops. And it's something that was banging our head against a brick wall, and it's something we were almost certain it was something that we was doing wrong. And again, which was great, I was able to quickly ring or email Otto about it, and he quickly told me about it. I'm getting chased up here to finish up quickly. So quickly, the other tip would be to apply a site north on your point cloud files, allow you to straighten all your pipework up, which is a huge benefit in Plant3D. And if anyone's interested in knowing more about that, please email me. And be strict with Smartsheet, especially with steelwork, just to make sure you've got consistency across all your steelwork. So this is a quick render of the finished product that we did. So you can see all the steelwork and the pipework, and a quick testimonial from the client. Like I said earlier, it was absolutely incredibly accurate. It was quick, it was cheap, it was fast, and they were really pleased with it. So thank you very much for your time, and apologies Excitec for taking my time on that. But please drop me an email, because I'd love to hear your thoughts on it, or request a brochure from us. But yeah, definitely visit our website. But I'll hand over to you. Thanks for that, Otto. Apologies for taking so long. Otto? Ah, there he is.
Okay. Thank you, Lewis. No problem. Great presentation. I just want to say before I turn it over to Daniel, to the next speaker, please feel free to put any questions that you may have. I mean, this webinar is for the benefit of everybody that's on the webinar. Go ahead and pick the presenter's brains if you have any questions, anything that you need to know. It is a learning curve also for you guys, so feel free to, again, put your questions in. At this point, I'd like to introduce Daniel Niziolek, and Daniel's going to take us through his case study with the gantries over the highway. So, Daniel, I'm going to turn it over to you.
Hello, everyone. I'm Daniel Niziolek. I'm the assistant engineer at Ramboll UK. So just a little bit about Ramboll to start off. So we're an engineering, design and consultancy company. We operate worldwide. We've got about 13,000 employees now in 300 or so offices in 35 different countries. And we have 16 offices here in the UK. I'm based in the UK in our advanced engineering team. And what we do is advanced engineering analysis, solving all sorts of complicated problems. We've been using laser scan data to build our models for about 10 years now. And we developed this term we called LAM at the time, which was basically the whole reality capture idea, really, to get our models into, for simulation and for BIM. So a little bit about the project itself. So this is all to do with Highways England upgrading their gantries with new signs and signalling equipment and so forth. And as part of this, they require as-built BIM models. And we identified edgewise and laser surveying as the tools to do that most efficiently. So here's a little partial map of the UK showing some of these structures. And you can see the red circle there. That is showing, I've blown it up on the right-hand side. So you can see, just in that little area, there's 5 or 6 gantries. Some of the challenges with this. So you may look at one of these gantries and you think it looks really simple. But when you actually get into the nitty-gritty detail, it's really not. So for example, if you look at a connection detail like the one shown on the right, you don't have a central node point between any of those members. So there's gaps between them for welding and so forth, which makes it really fiddly to model manually. Another example is that the boom, which is the horizontal member you see there running left-right, is actually curved because it's pre-cambered upwards, and it's sort of over pre-cambered effectively, which obviously is quite tricky. A key point to make here is just that as built, it's not perfect. It's not going to be vertical or horizontal, which is kind of what Lewis was saying earlier with his example. And another thing here is that each of these structures is unique and slightly different, and so we've got different spans, different heights, different signage, different member sizes, different bay widths, so on and so forth. And that's only looking at it globally. If you go into the minute detail, you see even more differences. Another challenge is that some of these gantries are accessible, so you can climb up a ladder and get on them and scan inside them. Others are only available from the road. The other problem is that we often can't get full road closures, or nearly always can't get full road closures, so we're limited in the access we can get to the site. And of course the biggest problem is there's just so many of these things. So I thought it'd be useful to just talk about some previous workflows before Edgewise. So one option we've used before quite often is to send an engineer up to site. He goes there with a tape measure and maybe a disto, a few bits and pieces like that, and he measures up as much as he can. He comes back to the site and our engineers will assess the gantry the best they can based on that information, but sometimes they don't have enough, they have to go back, so on and so forth. So it's a bit slow, error-prone, not ideal. Another option we developed was we started scanning them and then manually modelling them. But of course the biggest problem with this is it's just slow. Too slow, in fact, and too costly. So our new workflow with Edgewise starts off with a survey. So we actually specify these surveys now, knowing that Edgewise is our goal. And what I mean by this is, although you can capture nearly everything when you scan something, we're restricted in where we can put our scanners and the access we have on site. So we have to do the best we can with that. So we make use of, as best as we can, placing the scanner for getting as good at Edgewise data as we can. And what I mean by that is when we're extracting a I don't know, a square section, let's say, we need to have at least 2 faces of that in order to get a fit. So we might place the scanners, at different angles, at different heights, and so on and so forth to get the best we can. The primary goal of this is to model the key elements of each structure. And this is so that our engineers will have more confidence and more accurate results in their assessment of whether the gantry can actually carry new signs and signals and whatnot. It'll also be used to aid the design process, and potentially we're hoping to be able to use it for FEA down the line, but we haven't got there yet. As Lewis was saying, the structural modelling in Edgewise is a semi-automated workflow. Sorry, excuse me. Basically, we have to guide the system to give it an idea where to start and where it might find something. So you narrow down the parameters on what type of member it's looking for and what region of the data set it's looking in. And just a couple of tips on this. If you are struggling to get a match, try either using the clear view, which is like the scanner view, so like a true view, or the web share, or just set a clip box like I'm showing on the left there. And this will help eliminate anything behind the object, the desired object being picked up in the data. Another tool that Edgewise has is the still pattern extraction, which Lewis mentioned a bit. And this is a really, really powerful tool. And what it will do is allow you to take a feature you extract and search for it elsewhere in the data set. So on these gantries, I'm going to show you an example looking at the front and rear bracing that you see highlighted in orange and green there. So basically the key point to make here is that you need to think about this in advance. You need to know that you need to set things up so that you can do this more efficiently. So if I look at this here, so the first thing I need is I need to have some objects modelled beforehand that can be used to guide the process. So in this example, I need either the top or bottom bracing and the legs of the gantry. So I model the gantry in that sequence. I model the legs, then the bottom and top bracing. Then what I'll model is the first 3 diagonal bracings on the front elevation there. I model the first 3 because the first one is often unique. It's either a different angle or different size. And then I will pattern those 2 along the elevation using the bottom bracing as a guide. And then I'll go along, I'll fill in any blanks, I'll extend the members into the boom. And then once I've done all of that, I'll pattern select the whole thing back and then use the legs to pattern extract it over to the other side. And here's a few example images showing that. So at the top you can see just the first 2 members there. Then you can see the extract along the gantry. So you can see there's a few missing, but it's picked out most of everything. At the bottom you can then see the pattern extract to the other elevation. And a few words on the standard library. So Edgewise has the UK steel library built in, but you can also build your own custom ones. What I've actually done is built an optimized set of them, particularly for SHS, RHS, UK beam and UK columns. Because what you'll find is, because of the lack of coverage in our data, we often will find if you're looking at, say, a SHS, it'll have one face perfectly and then only part of another face. So it might pick an RHS instead of an SHS, and rather than going down that route, we just have them separate so that we know we're picking the right one to begin with. A bit about QA. So as Lewis mentioned earlier, the Smart Sheet is really amazing for QA because you see that section view there. and you see all of the points that are being used along that section. So you can see how good a fit you can get. I mean, those two examples are pretty amazing. Just to note that the algorithms that Edgewise use aren't 100% perfect all of the time, but it's really quick and easy to fix the errors usually. So a few things to try is the refit tool, which will try and fit it a little bit better to the points you see there. You've got a rotate flat tool. Sometimes it will find a match at an off angle or something, and you need to rotate it flat to the earth sort of thing. And the other thing is you've got side draggers, which will allow you to twist the member sort of out of plane slightly, which can often fix it. One of the other challenges I mentioned earlier was that the boom of the gantry is curved, so it's pre-cambered upwards, and it remains upwards after it's loaded. Edgewise can't model this as such, but what I've done instead is modelled segments of it along the gantry, and then in Revit I've gone in and drawn a spline through them, through the endpoints of those, and attached a 3D beam to that. This could be done in Revit, but I find it useful to actually extract the size of the member so that I get those benefits to begin with. And it also ignores any horizontal movement or twist along the member. Just one more quick tip for you. So these gantries, we scan them mostly at night, and we don't do colour because of that. And sometimes you find, because of the colours of the actual gantry and the textures and the finishes and whatnot, that the colours are just, the intensity values are just washed out. So it's all at one end or the other of the scale. But Edgewise has a nice feature in the model display settings called stretch colour. And if you apply that, it looks more like on the right of that image there. And you can actually see some detail, which is great. And I'll just finish up by talking about the time savings. So earlier in the presentation, I showed an example of a gantry that was manually modelled from scan data. And including the survey, that one took, I think it was about 4 days or so to model. Whereas the gantry you see at the bottom here, that was put together in 1 day, including the survey. Now, it varies a little bit for other types of gantries. There's some that are more complicated and so on and so forth, but that gives you an indication of the time savings you can get, which is quite phenomenal, really.